right. So our past series of videos has been dealing with using a soft-core Nios 2 processor on our DE10 standard board. This board has a Cyclone V FPGA on it, which also happens to have a dual ARM Cortex-A9 inside of that FPGA. That is referred to as the hard processor side. So today we're going to be dealing with starting to play with that hard processor side and how we get all the tools set up in order to do that. So that with that we'll get started. We actually don't even need Quartus today. We're just going to install some supplemental tools that we need and write a Hello World app running on that hardcore processor side. So the first thing we're going to need in order to do this is we need to download the Linux image, and we can get that from Terrasic's website. So if you go to the Terrasic website and you find the DE10-Standard board, we can click on the resources link, and you'll notice a number of things. We have the standard user manual, which we've been referring to. We've got the CD-ROMs available. But as we go down here, you're going to notice there's a section called Linux Board Support Packages. And these are basically micro SD card links. So we use a little micro SD card like that to do this with. And there's two. There's the Linux console, and then there's the Linux LXDE desktop. The desktop one is expecting a number of things to be in the FPGA and expecting the FPGA to be programmed, whereas the Linux console one has a bunch of drivers, but it doesn't try to initialize any hardware on the FPGA side. So we can actually use the Linux console version without having to program the FPGA. Now, I already have this downloaded and extracted, and it's sitting right here. It's the DE10-Standard_Linux_console.image. So I'm just going to plug my micro SD card in here real quickly. And right now it's just a standard one. It's formatted as FAT. So when this comes up, here we go. It's just labeled SD card and there's nothing on it right now. So I also downloaded a utility. It is the Win32 disk imager. And it looks like this. And basically with this, that SD card came in as drive E. I can hit my little open window here. And we'll go to the desktop, and I'm going to go down till I find that DE10 standard Linux console image. I don't need to specify a hash or anything. I can just go ahead and say, I want to write. And then it's going to say, are you sure you want to override? Why, yes, I do. Okay, my write has been successful. It's going to pop up a bunch of stuff that Windows doesn't understand because these are all Linux partitions. Just make sure you hit cancel on all those. One of them is a FAT partition, and you can see there's the U-boot, the SoC FPGA DDP, or DTB, and the Z image. But we are basically done. I can exit out of that, and then I'm going to safely remove my mass storage device so that I can plug it into my board. Alright, so there is our board, and I'm just going to plug my SD card in right over here and make sure it clicks into place. Okay, so now I've powered up my board, and one of the first things we need to do is we can hit Windows key X, and that's going to bring up our menu, and we can say Device Manager. And we need to go to the COM ports and see what COM port it came in as, and this one came in as COM3. So I'm just going to go ahead and close that down, and I'm going to go ahead and turn off my board again. And then I will fire up PuTTY. If you don't have PuTTY installed, it's a free utility. And basically, we're just going to set this to be serial. I'm going to change my COM port to COM3. And the baud rate we need is 115,200. Now, if you want, you can give this a name and save it so you can bring it back up later. I've already done that. So I've got my DE10-Standard COM3 here. So I can just double click on that. And that will bring up a serial terminal for my board. And as we can see, when I power this up, it's going to start booting Linux. And this is all running on that hardcore processor side. So we're going through the boot process. There we go. We're running Nstrom distribution SoC FPGA. And I can log in just by typing root, and there is no password. And there we go. Now, some things to know about that disk image. I have a 32 gig SD card, and it only created DF-H, wrong command. It only created a partition for root that is around 580 megs, right? So one thing that comes by default on this image is a shell script called expand root file system. So the first thing I'm going to do is I'm going to run that expand root file system. And it's going to say, hey, blah, blah, blah. We're rereading the partition table. It's busy. We need to reboot. And once you reboot, you need to run resize 2fs _ once. So we will hit the reset button on our HPS, and it will reboot our board. And we'll reboot Linux here. And then if I do, oops, I gotta log in first. If I log in as root and I do a listing, I'm gonna see that resize once. So we're gonna run resize fs2 once. And now, if I do a df-h, I'm gonna see, no, it doesn't look like it worked. So let's try that again. Expand my root file system. And then let's do a reboot. Let's actually shut it down properly this time and try it again. And here we are booting up. We'll log in and we'll run our resize. Once, there we go, that actually looks like it worked. And once we run that, that command should disappear. Now if we do a df-h, we should see that our available is now 27 gigs. So it filled up it moved that root partition to fill up the entire rest of my SD card so I can use it all. All right, so we're now running Linux on our hardcore processor inside that FPGA. I'm going to go ahead and minimize these for a minute. So the next step is we need to install the SoC EDS tools that come as an add-on to Quartus. Now the latest version that I could find on the website was 20.1, but those don't seem to be 100% stable with the Cyclone V, which is a little bit older device. So I downloaded the previous version, which is 19.1, and these tools seem to work really well with the Cyclone V. This was also one of the last versions. There used to be, it comes with ARM DS5 Studio, and this was one of the last versions that had a community edition of that. The newer versions required a license for the DS5. So I'm going to install the 19.1 because it's got everything and it seems to work really, really well. So we'll just go through this install really quickly. All right, here we go. And this is just the intro screen. So we'll hit next on it. And you'll need to read your license agreement. I already have, so I'm just going to accept it. I'm going to install this to Intel FPGA on my C drive, and it's going to go into the 19.1 folder. So we'll go ahead and hit continue there. I've already got Quartus installed, so I don't need to install the programmer. If you were just using this and you didn't have Quartus installed, you would need that. And then I'm just going to go ahead and hit next here. Alright, we finished the first part. After that gets installed, it brings up another thing. And yes, you do want to launch the FTDI driver installation, and you definitely want to launch the DS5 installation after that. So I'm going to go ahead and hit finish. That's going to bring up the FTDI COM drivers. We'll go ahead and say extract. And then we can install those. We'll hit next. And of course we accept. And there we go. There's our COM drivers installed. Next is the ARM DS5 installation. I'll go ahead and hit next. I'm going to accept the licensing terms. We'll hit next there. It's saying I needed a reboot, which was fine. I'm just going to ignore that. And I'm going to go ahead and install. Alright, it looks like we're just about done with our DS5 installation. And there are additional drivers that need to be installed for this, so we'll just hit next here. And we will install all of these drivers as well. Alright, I can go ahead and hit finish there. And that should be all we need to install the DS5 portion of our tools, and then we can start the next thing. Alright, and the last step to set up our D1 SoC toolset is to install the Cygwin tools. By default, they do not come pre-installed with the SoC EDS tools on this version. And if we go to our Intel FPGA 19.1 embedded, there is a folder called Cygwin setup. Basically, what we need to do is just run that batch file with the path to where our setup.exe is. So we will go ahead and do that. Make sure that you're running it in a command prompt with elevated privileges, so we need to run that command prompt as administrator, and then we'll just run the SoC EDS -Cygwin setup.bat, and then it is setup -x86_64.exe. And that is going to start the install of Cygwin, and this will take a while. So we'll, through the magic of video editing, we'll pop back in at the end of this. All right, so those are finished, and we now have our Cygwin stuff installed. The next step is to fire up the SoC EDS shell, which we'll go ahead and do now. You just find the SoC EDS command shell in your start menu, and it should start right up. Alright, so there is our EDS command shell. I'm just going to make this a little bit bigger. We'll make this just a little bit bigger so it's easier to see. And then I have created a directory in my video demo folder called Hello World HPS. So we'll switch into that folder, and then what we need to do is we need to write Hello World, right? So we'll start, I'm just going to create a couple new text files. We'll call this one hello world.c. Yes, I would like to change it. And we need another one, and we'll just call this makefile because we need a makefile as well. Yes, I want to change it. And if we look in our shell, we should be able to do a listing, and we'll see those two files. Of course, there's nothing in them yet. So let's also bring up one of my favorite editors, Notepad++, and we'll just bring both of these files into Notepad++. And we'll start with hello world.c. And this one is just your standard hello world, so we need to include standard io.h. We need a main, printf hello world, /r/n since we're in Linux. And let's return a 0. So that's basically our program. And the next thing we need to do is we need to write a basic makefile for doing our cross compilation. I'm going to go change my language. Oh, good. It already selected makefile. So first thing we got to do, let's define our target. We're going to say our target name is hello world. And then there's a few other things we need to define. We need to define our Altera device family. So this is SoC Cyclone V AV. We need to define our SoC EDS root folder, and we're going to call that $SoC EDS dest root. We need to define where our hardware libraries are, and those are in our SoC EDS root /IP/Altera _HPS HWlib. Couple other things. We need to define what our cross compile is. We'll set this to ARM-Linux-GNU EABIHF-. We need to define our C flags. So we want -G, -warnings all. We need a -D, capital D, and this one will be alt device family. We need an I, and that's going to be our hardware libs _root /include / alt device family. We need another one. This one's going to be $hardware libs _root /include. Oops, I forgot a parenthesis on that one. So that should take care of our C flags. Next, we need to do our linker flags, so our LD flags. That's just going to be -G -warnings all. We need to define our cross compiler, or our C compiler. That's going to be our cross compile, and we're using GCC. We need to define our architecture. That's ARM. And now we need to define our not ARM, that's just ARM. Okay, now we need to define our build rules. So we'll define one called build, and that is just dependent on the target. The target depends on hello world.o, and our rule for that one is our compiler with our C flags, -C for every one of those. We're going to produce for every C file, we're going to produce a .o file. So there we go. Next one is we've got a %.o. Colon %.c. Let's make that there. I don't need 2 tabs, I need 1 tab. Okay. And this one's the same thing. We need $CC, $C flags with a -C for $ less than, and a -O for $at. And blah blah. And the last thing we need is a clean rule. And that's just going to be an RM-F for $target, star.a, star.o, and let's remove any backup files as well. So there's our basic make file. And now our basic step at this point is we should just be able to run make. And I've obviously got an error someplace. I had a typo someplace in my make file. I basically just cut and pasted a known good one. I didn't feel like tracing it down. So here is the known good make file. I'll leave that up on the screen for just a second so people can pause and take a look. So there's our make file, there's our hello world C, and now if we run make, we will see, oops, I gotta do a make clean, and then let's do a make, and yes, I do. File, save as, hello world.c. Yes, I do. Save. Okay, for some reason, oops, my clean is messed up. That should be star tilde. Okay, let's try this again. Make clean. Our source files are there. There's our make. All right, so now we have our system built. We have Linux up and running over here. So the next thing I need to do is I got to transfer my file from my development station over to my board. So I'm going to log in over here as root, and I've got the network device plugged in, and I want to be able to transfer this via the SCP utility, which is a secure FTP based on SSH. So we're just going to do UD HC PC, which is going to run the a command that will cause the network stack to come up on the board and get ourselves an IP. And then we can do an IP config to find out what that IP was. So I see my IP is 192.168.1.33 is the IP I was given by my router. So what I'm going to do is come back over here to my shell, and I'm going to say SCP. We want to transfer hello world, and we're going to transfer it to root, because that's my user that I'm using on the board, at that IP address, 192.168.1.33, colon. The other thing I want to do, if we look, I am in /home/root, right? So I want to transfer this to the home root folder. We'll go ahead and hit enter on that. This will take a second, and then it should ask me, since I haven't transferred to this board yet, it should come back and ask me if I'm sure I want to do this, and there it is. Are you sure you want to continue connecting? You haven't connected to this device before, and we're just going to type in yes here. And of course, it's not going to update the known host, so it will ask me that pretty much every time. But there we go. We transferred hello world. I can come back over here and I can do a listing, and there is my hello world. And now we can run this on the ARM processors on that board. And there we go. There is our hello world. Now, there is one other way we could do this, and that is to use the DS5 tools. So we can run the DS5 tools on our system. This is not one of my favorite ways of doing it because I don't care for Eclipse as an editor at all. And this version of ARM DS5 uses Eclipse. It's firing up in the other window, so I'll drag it over here as soon as it's done, but we'll demonstrate how we can use the DS5 Development Studio as well. So first things first, it's going to want me to set up a basically a workspace. So I'm going to come out here, and we're going to go down to our video demo folder. We're going to go into our Hello World HPS. I'm going to make a new folder, and we'll call it DS5 dash Hello World. And that will be where I put my workspace. All right, here is the DS5 Development Studio. This is, again, is an older version. This is basically the community edition. Some of the features are disabled, but what we want to do is a new C project, and we want to go down here. We want an empty project, and we want to make sure we're choosing the ARM Linux compiler. We'll give this a name. We'll call it Hello World-DS5. We'll go ahead and hit next. Sure, give us a debug and a release. And I'll go ahead and hit finish. So there is our basic. There's our basic includes. And I'm just going to say we want to do a new file. No, I want to do a new source file. No templates, and we'll just call it Hello World.c, and I'll go ahead and hit finish. So there's our Hello World.c file, and we can do our same basic program, standard io.h, int main, void, printf, hello world from DS5, /r/in. Change it just slightly so it says something different. And then, of course, our return 0. So there we go. I can save that, and I can go ahead and I can build this project. And we can come down here to our shell, and we'll see we have that DS5 folder in there now. And inside that DS5 folder, we have our project. We should have a debug folder, and inside that debug folder should be our Hello World DS5. So I'm just going to hit up arrow a couple of times, and we're going to add a -DS5 to that and just copy that over as well. And there we go. If we do our listing, there's our Hello World DS5. They are different sizes because that's a debug build. Also, different number of letters. And there is our Hello World from DS5. So that are the two ways we can write programs for the embedded hardcore processors inside the DE10. Basically, my preferred method is just Makefile solution, so I can use whatever editor I want. Visual Studio Code, Notepad++, what have you. DS5 uses Eclipse. I'm not a fan of Eclipse, so I tend to stay away from that. However, they're both available. And with that, that will conclude this tutorial on how to set up our tool set and write a simple Hello World application on the hardcore processing system inside the DE10 standard.